Right.
Friends, today's topic is physical constraints in crop production, or the physical problems associated with the soils for crop production. First, let us appreciate the fact that usually we attach much importance to the chemical fertility of the soil, and we don't give much importance to the physical fertility. Therefore, what I want to highlight is the physical fertility of the soil is equally important, and it is as important as the chemical fertility of the soil, including the biological fertility of the soil. With this background, first let us list out the important physical constraints for crop production. The most important one is the soil compaction. The second one is soil crust. The third one is the slow permeability of the soil. Fourth one, high permeability of the soil is also a constraint. Fifth one, soil erosion. Sixth one, the soil hardening. Seventh one, the shallow depth of the soils. And the eighth one, the presence of hard pans, etc. These are all the important physical constraints associated with the soils. Now let us discuss each of these constraints in detail. The first one is the soil compaction. Soil compaction simply refers to the increase in density of the soil under an applied pressure or load. I mean, when pressure or load is applied, soil becomes compacted. This means that the mass per unit volume decreases. Consequently, the density increases. And of course, the soil compaction also includes the soil compression. Then, what is soil compression? Soil compression refers to the decrease in volume of the soil under an applied pressure or load. When soils are compacted, the various soil particles are reoriented, and thus their volume decreases. Actually, the volume due to the pore space gets reduced. Now, let us discuss about the important factors that affect the soil compaction. There are four important factors. The first one is the nature of the soil or soil particles. The second one is the moisture content of the soil. The third factor is the amount of energy or pressure or load applied. Fourth one is the extent of manipulation of the soil. Usually, the fine textured soils can be subjected to greater compaction as compared to the coarse textured soils. Say, in case of coarse textured soils, the sands and silt particles are difficult to compress. They are difficult to compact. This is because they possess very high internal friction. Because of the high internal friction, the coarse textured soils cannot be compacted to a greater degree as compared to the fine textured soil. Coming to the second important factor, it is the soil moisture. Normally, with increase in soil moisture content in the soils become more compacted. Actually, the increase in compaction or the soil compaction increases up to certain moisture content, but beyond the addition of more amount of moisture to the soil doesn't increase the soil compaction or doesn't increase the soil density. I mean, only up to certain moisture content, the soils become more compacted. But after certain moisture content of the soil, then you cannot expect the increase in density of the soil. The moisture content at which the greater compaction of the soil can be achieved is called the Proctor moisture content. I mean, at this moisture, the soils can be compacted to a greater degree. Beyond the Proctor moisture content, you cannot compact or you cannot increase the compaction of the soil. Coming to the third important factor, that is the amount of load or pressure or energy applied. Naturally, higher the load or higher the pressure applied, greater is the compaction. Coming to the fourth important factor, that is the extent of manipulation. Usually, with increase in the extent of manipulation, the soils become compacted more and more. Then, what are the problems associated with these compacted soils? The first one is in case of compacted soils, the root growth is restricted. Secondly, when root growth is restricted, the plant growth gets upset. Thirdly, since roots are spread in the shallow soil system or in the shallow depth, they cannot exploit more water and nutrients from the soil. I mean, the availability of water and nutrients get reduced in compacted soils. Similarly, the air availability is also reduced. In case of paddy field, when these fields are plowed, there will be formation of a compact layer, particularly at the bottom zone of plowing. This compact layer is called plow soil. It is called plow soil, particularly in paddy fields. This plow soil, a compact layer, is formed mainly due to the weight of the plow. Then, how to manage these compacted soils? The compacted soils can be managed by chiseling or by deep plowing. I mean, we have to break the compact layer. And of course, the profile modification is also suggested for the management of compacted soils, but profile modification is not practical. The second important measure is the application of liberal amounts of organics. I mean, the application of FIM or raising the green manure crops or green manuring in situ or green leaf manuring, etc. However, in case of coarse textured soils, soil compaction is a bore. I mean, when coarse textured soils are compacted, actually the microporosity increases. Consequently, the water holding capacity of the soil and also the nutrient holding capacity of the soil increases. Therefore, in case of coarse textured soil, compaction can be a bore. Then coming to the effect of compaction, particularly on the soil moisture status and the temperature status of the soil. Usually, the soil moisture status decreases, but the temperature status of the soil increases when soils are compacted. Coming to the second important constraint for crop production, it is the soil crusting. Actually, The soil crusting is a process of the formation of soil crust. Therefore, first we shall define what a soil crust is. Soil crust is a thin, compact layer of soil of very high bulk density and low non-capillarity formed at the soil surface due to the disintegration and dispersion of the natural soil aggregates as a result of irrigation or under the impact of raindrops and its subsequent rapid drying under the radiant energy of the sun. This is the definition of the soil crust. If we study the formation of the soil crust, it will be very clear. I mean, when raindrops hit the bare surface of the soil, the natural soil aggregates are broken down. I mean, the natural soil aggregates are disintegrated and dispersed. The various primary particles, particularly sand, silt, and clay particles, are detached when raindrops hit the bare surface of the soil, and thus the muddy soil suspension is formed. I mean, the clays slake down in rainwater and there will be formation of muddy suspension. The finer clay particles, I mean the dispersed finer clay particles, actually move down along with the infiltrating water and they plug the soil pores beneath the soil surface. I mean, the soil is sealed. Its macropores are plugged. Consequently, the soil surface is sealed. As a result, the downward movement, I mean the infiltration, almost stops, and of course there will be some amount of runoff also. However, the muddy suspension starts accumulating at the soil surface. At this time, the particles of the soils that are dissolved in soil suspension start settling owing to the Stokes law. You know that according to Stokes law, the coarser particles settle first to the bottom, followed by the finer particles. Therefore, here the sand particles settle first, then the silt particles settle, and the clay particles settle only at the end. At the same time, there will be the drying up of the soil suspension due to the radiant energy of the sun. Finally, the clay particles accumulate over the sand and silt particles, and on drying, there will be formation of curved layers, and on complete drying, they become very hard with very high bulk density and very low non-capillarity. These layers, curved layers, are called the soil crust. Coming to the properties of soil crust, first one, the soil crust have very high bulk density and low non-capillarity. And second one, the soil crust have very high strength. The third one, the infiltration rate and the hydraulic conductivity are quite low in these crusted soils. Fourth effect, since the infiltration rate is quite low, the rain water simply runs over the land as runoff. Therefore, the top fertile soil is subjected to erosion. And the last effect is the applied nutrients are also subjected to the various losses. Coming to the factors affecting the soil crust formation or the soil crust strength, the most important factor is the size of the raindrops and the intensity of rainfall. Bigger the size of the raindrops, greater is the impact on the land surface. There will be greater disintegration and dispersion of the natural soil aggregates. Therefore, if the size of the raindrops is more thicker and somewhat greater, thick crusts are formed. And definitely, with increase in intensity of the rainfall, there will be greater destruction, and thus the thicker crusts are formed. The second important factor is the organic matter content of the soil. Usually, organic matter enhances the soil structure. I mean, it improves the soil structure. In presence of higher amounts of organic matter, these stable soil aggregates are formed. These stable aggregates are somewhat resistant to the breaking effect of the raindrop. I mean, they prevent the disintegration. I mean, the stable aggregates prevent the disintegration and the dispersion of the natural soil aggregates. Thus, with increase in organic matter content in the soil, the crust formation or the somewhat smaller and somewhat weaker crusts are formed. The third important factor is the ESP of the soil. If the ESP of the soil is more than 15%, definitely such soils are prone to crusting. The fourth important factor is the silt content of the soil. Normally, silt and silt loam soils are more prone to crusting. It is said that soils with 60% coarser fractions, particularly dominated by silt particles, and 40% finer fractions are more prone to soil crusting, particularly when the organic matter content of the soil is less than 1%. These are all the important factors that affect the soil crusting. Coming to the measurement of soil crust strength, the soil crust strength can be measured by three important methods or by three means. The first one is by the use of penetrometer. The second one is the balloon pressure technique. The third means is the modulus of rupture test. Modulus of rupture test, balloon pressure technique, and the penetrometer technique are used for the measurement of the soil crust strength. However, usually we employ the penetrometer to measure the soil crust strength. Penetrometer is steadily pushed into the soil, and the resistance offered by the soil to the process of penetration is measured on the body wall of the penetrometer tube, and the pressure is measured in kgs per centimeter square. Coming to the management of crusted soils, there are 5 important management practices. The first one is the mulching. You know that mulching refers to the covering of the soil surface with the crop residues. I mean, when soils are mulched, the raindrop impact is on the mulch. Therefore, the soil aggregates are not subjected to the disintegration and dispersion. There will be minimum damage to the soil aggregates, and thus mulching prevents the or minimizes the crust formation. Secondly, mulching also helps the rainwater to get infiltrated more into the soil. Coming to the second important practice, it is the growing of closed space crops such as legumes and grasses. Legumes and grasses cover the soil to a greater extent. Actually, these legumes and grasses, legumes particularly groundnut, they can cover the maximum the soil surface so that they act as live mulches. Coming to the third important measure, it is the application of FYM. FYM increases the stability of the soil aggregates. The stable aggregates resist the dispersion and breaking down of the aggregates. Therefore, with increase in application of organics, the soil crusting is minimized. The fourth important measure is the application of crop residues, particularly the residues of various crops, say cotton, tur, maize, etc. They also reduce the soil crusting. The fifth measure is the application of chemical amendments, particularly gypsum, when the soil ESP is more than 15%. You know that gypsum is an important chemical amendment. It reduces the soil acidity. It reduces the soil sodicity. When soil sodicity is reduced, the dispersion of the natural soil aggregates also reduces. The last measure is the keeping the soil always moist by giving light but frequent irrigation. This means that you have to keep the soil always under moist condition so that the crust formation becomes minimum. Coming to subsurface mechanical impedance. The third important constraint is the subsurface mechanical impedance. The subsurface mechanical impedance may be developed mainly due to 4 important mechanisms or factors. The first one is due to the use of heavy machineries, particularly tractors and moldboard flows. The second important factor is it is the formation of flows zone, particularly in rice fields. It is the formation of a hard compact layer, particularly at the bottom zone of the flow in rice fields. The third important factor is, the subsurface mechanical impedance may also develop due to the accumulation of clay in subsurface beef horizon, particularly in humid and subhumid conditions. The subsurface mechanical impedance also develops due to the presence of canker layers, that is calcium carbonate layers. Then, how subsurface mechanical impedance affects crop growth? When there is a subsurface mechanical impedance in the soil, the root growth is restricted. The roots cannot extract nutrients and water from the deeper layers of the soil. Secondly, the soils become highly prone to waterlogging. The third effect is when soils are waterlogged, there will be oxygen stress. The crops, particularly roots, suffer due to want of oxygen. There will be formation of, or there will be the weed infestation, etc., due to the subsurface mechanical impedance. Coming to management of subsurface mechanical impedance, the best practice is the ploughing or the chiseling of the soil and the breaking down of the clay paths, particularly in beef horizon. And of course, profile modification has also been suggested, but it is not practical. Coming to the next important physical constraint is it is the shallow depth of the soil. Normally, when the depth of the soil is below 20 centimeters, such soils are called shallow soils. Then, which are the problems associated with shallow soils? The most important one is it is erosion. The shallow soils are subjected to greater erosion, particularly by wind and water. When the topsoil is eroded, huge amounts of nutrients are also subjected to losses. Secondly, in shallow soils, root growth gets upset. Root growth is confined to the soil surface. Then, how to manage these shallow soils? The best management practice is to adopt the soil and water conservation measures. You know what I mean. What are the important soil and water conservation measures? It is the cultivation across the slope, contour bunting and bunting, or zinc terracing, etc. These are all the soil and water management practices. Coming to the next important constraint is it is the hardening of the soil. The red sandy clay loam soils of Andhra Pradesh become very hard due to their low moisture holding capacity. These soils are called chalka soils. Particularly, they are famous in Andhra Pradesh. Therefore, we say that the chalka soils of Andhra Pradesh. These soils are suffering mainly due to hardening. You know that when soils become hard, the germination, the percent germination is very, very poor. Secondly, the root growth is also restricted. Then, how to manage these chalca soils? As far as the management of chalca soils is concerned, two important technologies have been suggested. The first one is it is the crop residue recycling technology. This technology involves the use of or the incorporation of very high CN ratio organic materials, particularly powdered groundnut shells or rice bosa. These materials are incorporated into the soils. The second important management technology, particularly for chalca soils, is it is the seed line mulch technology. This involves the application of liberal amounts of organics, particularly FIM or wheat busa, at the rate of 25 quintals per hectare all along the seed line. After sowing off the crops such as cotton, millet, wheat, etc. Coming to the next important constraint is it is the high permeability of the soils. You know that high permeability is associated with coarse textured sandy soils and sandy loam soils. Usually, these soils are quite common in Punjab, Haryana, and Rajasthan. Usually, the hydraulic conductivity of these soils is more than 0.15 centimeter per hour, and the infiltration rate is more than 0.2 centimeter per hour. Actually, it is more than 36.5 centimeters per hour. The high infiltration rate and high hydraulic conductivity clearly indicate the high permeability of these soils. Then coming to the problems in highly permeable soils. In these soils, the water holding capacity decreases. The soils are prone to frequent droughts. Secondly, the nutrients are subjected to leaching losses. Thirdly, these conditions do not encourage farmers to go for high rates of application of inputs, particularly high amounts of fertilizers and high irrigation. The question is how to manage these highly permeable soils. The best management practice is to compact these soils. We have to pass a roller weighing approximately 500 kilo made of either metal or stone for about 4 to 5 times in order to achieve a desirable compaction. The highly permeable soils need to be compacted to a desirable level. When the soils are compacted, the microporosity enhances at the expense of macroporosity. Consequently, the water holding capacity and the nutrient holding capacity of the soils increase. The second important practice is the application of organic manures. And the third important practice is the application of pond sediments, or it is the mixing of these coarse textured soils with more quantity of clay or clay soils. These processes decrease the bigger or macro porosity and increase the micro porosity. Coming to the last important, the physical constraint is it is the slow permeability of the soils. You know that the slow permeability is associated with the fine textured soils, particularly black soils. These fine textured soils occur in mainly in states like Madhya Pradesh, Maharashtra, Karnataka, parts of Rajasthan, Uttar Pradesh, Tamil Nadu, etc. I told you, no, the slow permeability is associated with the fine textured soils. In these soils, the infiltration rate is below 0.2 centimeters per hour and hydraulic conductivity is below 0.15 centimeters per hour. The low infiltration rate and the low hydraulic conductivity clearly demonstrate that these are all the slowly permeable soils. Coming to the problems associated with slowly permeable soils. First one, these soils are prone to water loss. Secondly, there will be oxygen stress. Thirdly, in waterlogged soils, some undesirable compounds are formed and they may become toxic to the growing plants. And finally, there will be greater weed menace. These are the problems associated with slowly permeable soils. Coming to management of slowly permeable soils, one important technology called raised and sunken bed technology has been proposed for the management of slowly permeable soils. This technology involves land shaping. In using this technology, land is converted into raised beds and sunken beds. Normally, the height of the raised bed is 20 centimeters and the width of the raised bed is 3 meters, whereas the width of the sunken bed is 6 meters. Such raised and sunken beds are formed throughout the field so that one can grow the normal crops on the raised bed, whereas in sunken beds, usually these sunken beds are waterlogged. Therefore, in sunken beds, the rice can be suggested or rice can be grown. This technology is popularly known as raised and sunken bed technology. The second important practice is it is the application of organics and also the crop residues and also the application of phosphatic fertilizers are also useful for such slowly permeable soils. This is all about the physical constraints associated with the soils. Correct? Mugitar. Hello, ನಾನು ಫೋನ್ ಹಚ್ಚಿದ್ದೆ ಹಚ್ಚಿದ್ದೆ ಅಮ್ಮ ಕ್ಲಾಸ್ ಹಚ್ಚಿದ್ರೆ ಕ್ಲಾಸ್ನಾಗಿದ್ದೆ ಅದಕ್ಕೆ